reflex motion technique. To understand this detection method, we need to understand the concept of reflex motion. In a planetary system, the planet is not the only one with an orbit. Because of gravitational interactions, the star will be attracted to the planet as well, causing it to wobble around a common center of mass. The motion of the star, due to the presence of the exoplanet, is known as reflex motion. When looking at the spectrum of a star, we can use the Doppler effect to measure the little velocity variation. As the star moves relative to the Earth, the measured spectral lines will appear to move. When it moves towards the detector, they will appear redshifted. When, on the other hand, it moves away from it, they will appear blue-shifted. So, if the spectrum of a star is measured for a long period of time, the presence of a periodic Doppler shift can reveal the existence of an hidden exoplanet. This technique, however, has some limitations. If the exoplanet is not massive or close enough, it won't cause the star to wobble as much. Also, the velocity measurement is highly dependent on the inclination of the orbit with respect to the line of sight from Earth. A more inclined orbit will result in us detecting a smaller wobble, harder to see, and planets whose orbit is perpendicular to the line of sight will not be found at all. Astrometic Method. The idea of the reflex motion is also the key concept behind another detection method, astrometry. The observed star movement in relation to other stars. The amplitude of the reflex motion can be measured directly by keeping a record of several extremely precise measurements of the star position in the sky over a long period of time. This detection method is by far the oldest, dating back to the 18th century. But despite its long history, it is by far the least successful, with only one exoplanet being discovered. Planet VB10b, found in 2009 by telescope Hale after 12 years of observations. Move on to the next video to find out about other detection methods.